Okay, hello everyone. I'm just recording here another short supplemental video to talk a little bit about the string type in some more detail. We'll explore some of the methods that were mentioned in the lesson, and we'll also look a little bit at the char data type in some more detail. So we've kind of already seen chars being used in our programs, but we haven't explicitly spoken about them or used them as variables. So I just want to explore a little bit more with what we can do with the various string methods and yeah, just give you some other stuff to try and play around with and so you can have some fun. So again here, I've just got a really simple project started. I've called this lesson 2 strings and chars. Again, you can go ahead and create your own demo project to play around in. And like other supplemental videos, I'm not going to base this on a program. I'm just going to run here with a basic console.writeLine statement. Maybe we'll include a bunch of them, but one is good for now. And again, the point here is just to see what we can do with strings, the different methods that are available, and then also how we can work a little bit more with chars and how chars are different from strings. So in the scaffold here for the program I have, we've got our console write line with just a literal string value of hello world. And this is enough to begin with. Because this itself is a string, even though it's within quotes and it's the literal value, we can still do all of the string things with this literal value that we could with a string variable. So on the end of the string, if you just hit the dot operator, you get access to all of the different properties and methods that a string has. So this is one way to go about doing it. So we could capture and here write out the length of the string. So if we access hello world.length, we can see that it's got 12 characters, so that's fine. Or we could have created a variable, and I'll just call this message, and we could have done that. Oops. And assign the value here, and done the same thing, calling the length property on the MSG or the message variable. So when you see me using literal values in my demonstrations or my lectures or my supplemental videos, just know that I'm doing that to show the explicit type that's being used. But of course, you can always use variables of the required type in place of the literal values. You're not stuck with just having to use literal numbers and strings. That would make working with the programs very difficult. Variables of the required type are obviously just as good. So here again, we can see that we get a 12 character count on our string message. Okay, and so some of the other methods that were looked at, we've seen already the 2 upper and 2 lower methods being used in previous lessons, but we can explore some of these other ones. So for example, we'll be looking at making comparisons to help us with making decisions in our programs. And the compare to and the equals methods are both 2 methods that will allow us to do that. I'm going to update this string to something a little bit simpler to work with. I'll go with the ABCD example that's used in the lesson. And so we could, for example, check whether or not this particular string equals another string by doing the comparison this way. Okay, so now this will return a Boolean result, either true or false, which I'm just going to assume everyone is somewhat familiar with. But in a follow-up supplement video, I'll talk a little bit more in detail about Boolean types. But for now, we can determine whether or not the value that's in this message equals the passed-in string here, ABCD. And so I would expect that they are the same since they match, and we do get a true response. So equals can be used to compare strings for equality. The compare to method can be used to check strings lexicographically to see that one string comes before another in terms of alphabetical order. So we can do that as well, and I'll save that for a follow-up video. One of the other things that are looked at here in terms of strings are the substring. So this is oftentimes useful too. So we might want perhaps not the entire string, or maybe we want a piece of it. So we want to pull out a substring. Maybe I'm interested in only the first several letters or characters of a string. I'm not interested in the whole thing. Or I'm interested in pulling out a piece. Let's say we have a hyphenated word. I'm interested in the second part that comes after the hyphen. So there are methods that we can use to access different pieces of the string that way too. So if we call the substring method, we can see up in the tooltip that it takes a start index, but there's an overload as well, which is to take a start index and a length. So if we call substring and we specify an index of 1, that should give me a substring of the given string that begins at the second position, right? So index 1, we know that the first position is index 0. So I would expect if I run msg.substring that begins at position 1 to get a BCD substring result. And again, we can test it out to see what we get. And sure enough, there is the BCD result based on getting a substring that began at position 1. If we wanted position 1, but we were interested in only 2 characters from that position, then we could pass a second argument, which is the length value. And so we can use the substring method in one of 2 ways: to start at a position and run to the end, or to start at a position and capture only so many characters from that position. Oops, I've got an error. It's telling me right in my face. So here, beginning at position 1, which is the B, but only running for a run of 2 characters, I get the B and the C, and I don't see the D come out in the substring. So again, another way that we can use the substring method. It's not only a starting, but we can say start and for how many characters. And so again, I'm not going to run through all of them here, but there's a lot of methods that are available, and I recommend having a look at them. A couple of other ones that are useful are the trim methods. So when we talk more about exceptions and exception handling coming up in week 4, then we'll be able to talk a little bit about, well, what happens if the user enters in something, but it's blank or it's empty, and that's not what we expected. The trim methods, either trim end or trim start, or just trim, which does both, are quite useful. So I'll just demonstrate the trim method here quickly. So if we add a couple of space characters to our message value and we display that, these are not taken away. These are included. So spaces are valid characters in C#. They're not just going to disappear. So here you can see the output does include the spaces. I can only see the spaces in the beginning of the string, but trust me, the spaces on the end are there as well. So if we were not interested in white space, we could use the trim method. And like it says here, it writes, that's not what I want, string here. It removes all the leading and trailing white space characters. So in this example, this would be leading white space, and this would be trailing white space. So now I would expect to see just A, B, C, D without the spacing in the front or the end. And of course, there it is. So the trim method is nice for cleaning up input. Where it's useful in terms of tracking empty input are cases like this. So if there are only white space characters in the string, then calling trim will effectively reduce that string to a length of 0. And we could treat that as an empty string, and then maybe we would reprompt the user for input. So if we asked for something and they hit enter without providing any values, we could detect that, and then we could respond with a reprompt. Or if they wanted to get smart and try to test the system, and maybe they just entered in a bunch of spaces, then the trim method will get rid of those white space characters and still reveal that, well, it was really an empty string. You didn't provide any value. So again, many other methods in there. Have a look at them, mess around with them. Now, the second piece that I wanted to look at in this quick little video was the char type. So strings are strings, and really they're just collections of individual characters or chars. So in this string that I have here, I've got 4 characters or 4 chars that are combined together and wrapped up inside this idea of a string. And that's what makes a string an abstract data type, is it actually hides the internal representation of what it is. But it's possible for us to pull individual characters out. So if we want to represent an individual character, we use the char data type. And so, for example, if I was interested in the first letter from my string as a char, we can access that using the bracket notation on the string variable. So here I'm saying access the message variable, and then inside the brackets, I can specify an index, and that effectively plucks a char out of the string and now allows us to do really whatever we want with it. In this example, I'm just going to assign it to a variable. But you'll see there's no error messages that come up and everything is fine. And if we try to do a write line of that first variable, we should see that we get the letter A, or the character A, printed to the screen. Okay, and there it is. Now, if we were trying to assign that to a string, you'll see that we get an error because using the bracket notation tries to pull out a character. And you'll see here, oops, we get this red line, and it tells us it cannot implicitly convert from type char to string. And that's because chars are inherently numeric, right? So each individual character is represented with a numeric value. And a string is an abstract data type that is actually a collection of 0 or more chars. And so we can't convert from just like a number to a string. It doesn't know how to do that. So if you ever do find yourself having to work with individual single characters, then the char data type is what you're going to be interested in. And again, because of the fact that each unique character has a unique numeric value, while you might have letters that have both upper and lowercase representations, those representations are different. They are different numerically. And so, for example, a lowercase y does not have the same value as an uppercase y. So those two characters or chars would not be equal. And that's in part how we get case sensitivity. So yes, and so chars are somewhat useful in, again, certain circumstances, and we'll come across some of those in some of the exercise and practice problems that you're presented with. But for now, it's just good to know that they're an option, and they can be useful. Again, they're numeric, so you can do direct comparisons. I'll talk about that more in the next Boolean and relational operators video, but you can just do direct comparisons. You don't need special methods like equals or compare to from the string. You can just use less than or greater than or equals to with char values. So they're a little bit easier to work with in terms of trying to do comparisons than strings are. But yeah, so that's that. It's a little bit more detail about strings and chars and how they work. Again, I recommend you just fire up a small little program like what I've done here and just start experimenting with the different types and the methods that are available to see what you can come up with. And again, just become more familiar with the language and how it can be used. So that's it for this one. I'll see you in the next video.